All right, welcome ladies and gentlemen to section 2.8, solving equations in one variable. That might sound pretty simple, and it kind of is, but we're going to be looking mostly at fractions, we're going to be looking at cross multiplication, and we're going to look at things called extraneous answers. So let's go ahead and take a look at what we're going to be doing today. So the first word that we're going to look at is fractions, which require some denominators. You might recall how to solve some of these problems as we get going here. But what we need to do is we need to be able to clear the denominators, make the problem simpler so we can solve it using all of our previous knowledge that we have from Algebra 1 and Algebra 2. So here's our first thing. We need to multiply by the common denominator to clear all fractions. Once we've cleared all the fractions, we get to solve as normal. So let's take a look at what might be a very simple example, something from an Algebra 1 level class. This would be an Algebra 1 level class here, or question. Now, quite honestly, we could just go subtract, we could do all sorts of things, but the easiest thing to do in this problem is to multiply by the LCD. The LCD in this case, if you guys remember, that's the least common denominator. In this particular case, the LCD is 6. That's the lowest number that goes into, or that 2 and 3 both go into. So I'm going to multiply this entire equation by 6. So I'm going to take the 6 and I'm going to multiply it by 1/2, and I'm going to get 3 times the x. Then I'm going to take the 6 and I'm going to multiply by the 3, and I get a 2. And lastly, I'm going to multiply by that 4, and I'm going to get 24. And then you solve this as normal. So that's why I said solve as normal. Subtract 2, divide by 3, I get 22/3. So that would be an Algebra 1 level question. It's still a linear function, and that's the only thing you're going to have to do. Now, the problem is we're not in Algebra 1. We're in Algebra 2. And above, obviously. We're above Algebra 2. We're going to take x plus 3 over x equals 4. Then we're going to do the same thing as before. We want to get rid of the denominators. And the only denominator here is x, so we need to multiply by x. When we multiply by x, we're going to do the same thing here. We're going to distribute all the way across this equation. When we multiply by x, we get x squared. When we multiply by that 3 over x, the x is canceled. We're left with 3. When we multiply by 4, we get 4x. Now, this is a quadratic. Quadratics we have to set equal to 0, and therefore now we can factor. So x minus 3, x minus 1 equals 0. Therefore, x is 3 and x is 1. Now, you should probably double check, make sure both of these answers work. So if I plug in a 3, I get 3 plus 3 over 3. Does that equal 4? Of course it does. 3 over 3 is 1. And if I try the 1, I get 1 plus 3 over 1. Does that equal 4? Yes, of course. Therefore, our two answers are 3 and 1. All right? But really, the big thing came down to multiplying by this x in order to cancel all of our fractions. But what if we had a more challenging looking problem? Because that's what this class is all about, making the problems harder. So let's look at x plus 1 over x minus 4 equals to 0. Now, it doesn't really look a whole lot harder. It actually almost looks easier, but maybe the work gets a little bit harder. Here, the only denominator is x minus 4, so I have to multiply by x minus 4 everywhere. When I multiply by x minus 4 here, I get x times x minus 4, and you can distribute that if you want to before you write it out. If I multiply by here, that cancels and leaves me with a 1, and I get a 0. So here I get x squared minus 4x plus 1 equals 0, and this one is not factorable. I'm going to leave the quadratic formula to you. But having done the quadratic formula, you should get 2 plus or minus radical 3. Okay, some of you are saying, well, Mr. Allison, that wasn't really very hard. How about a harder one? Okay, I can do that. What about 2x over x minus 1 plus 1 over x minus 3 equals 2 over x squared minus 4x plus 3. Well, we've just ramped up the difficulty a little bit, but the process still is the same. I want to multiply by the LCD. And what I always tell people is, don't just take all 3 of these and multiply by all 3. Look at your problem first. This factors to x minus 3 and x minus 1. And if I factor it like that, my LCD is x minus 3 and x plus 1. Which means I'm going to multiply by x minus 3 and x plus 1. Sorry, I don't know where the plus 1 came from. My fault. Minus 1. When I multiply, I go and distribute to all 3 pieces. When I multiply by the first one, the x minus 1 cancels, so I get 2x times x minus 3. When I get the second one, the x minus 3 cancels, and I'm left with 1 times x minus 1. And it's equal to, okay, the x squared minus 4x plus 3 is x minus 3x minus 1, and therefore it's just left over as a 2. And look here, we now have a simple problem we know how to answer. 2x squared, or how to solve, minus 6x plus x minus 1 equals 2. We simplify this to 2x squared minus 5x minus 3 equals 0. This will factor to x, 2x, plus 1, and x minus 3. So here we get x equals negative 1/2 and 3. But here's a problem. If I was to plug in these numbers, if I were to plug in these numbers, notice the negative 1/2 is okay. Nothing happens. But what happens when I plug in a positive 3? Well, it makes this one 0 in the denominator, which means this one is not a solution, and that one would be our extraneous answer, our extraneous solution. You could also come down to a problem where both of your answers were extraneous. And if both of your answers are extraneous, then you would have a no solution problem. There is no solution to the given problem. I'm actually going to leave it here. That's all that I have for you. It's a relatively short lesson. It's a relatively short, kind of easy to do assignment. I hope you guys learned a little bit of stuff anyway, and I will see you guys tomorrow.